Proficiency comes from action, not the other way around. It's not the degree I use at all. Most of my work is being extremely uncomfortable. Always be blogging. You all are wondering if I'm an alien or not.
I do.
Your prior belief, I think I should take the hint. Everything is intertwined. If you want to feel that overestimates their own capacity, look at politics. Fail faster, fail better, and start with small incremental steps. You're saying we shouldn't fly planes, we should only take the trains. Usually they are Europeans, I have to say. Maybe LLMs will be funnier at some point. To me, that's one of the most interesting questions. As a scientist, I need to control myself sometimes.
Alex, you are a senior data scientist, co-founder of several Bayesian-focused companies, host of the Learning Bayesian Statistics podcast, where you have over 12,000 monthly listeners, and it's one of the largest Bayesian communities, and also an open source contributor. How do you do all of this?
I do not sleep, but no, that's not true. I actually need to sleep a lot, so I am very careful about my sleep schedule. Everything is intertwined, so I don't think I would be able to do so many things if they were completely parallel. That'd be very hard. I actually tried doing that because I'm a very curious person and I'm restless. So I want to do so many things, but I tried doing different things, very, very different. And that is too hard. You can't. So at least I can't. So yeah, what I do is that everything is interrelated. I think somebody who puts that very well is Nate Silver. He's the guy who popularized electoral forecasting in the US, had this website called 538, and his philosophy is always be blogging.
One of the questions I ask myself oftentimes is whether you have to be really good at your work to start contributing to open source projects. Because a lot of people, they have imposter syndrome, including myself. I feel like you have to be pro in programming to start contributing to open source projects. What do you think?
Yeah. The field is full of imposter syndrome, which honestly, if I had to choose one pathology for a field, I think it's a good one to have. Like, it's much, much better to have people underestimate their skills than people overestimating them. If you want to feel that overestimates their own capacity, look at politics. Mostly, that is not a good way of handling things, I would say. So I prefer that. It's easier to solve because, basically to answer a question, no, you do not have to be that proficient. Like, proficiency comes from action, not the other way around. So just pick something small and then improve along the way. That's really how it's gonna go. First, because you will learn by yourself, but mostly because you will learn from other people who are more experienced than you in what you're trying to do, and so you'll have very good mentors along the way. Especially open source is full of very good people who do a lot of work for free and who don't do that for the money. They do that because they love it, and so they will be able to help you. Like, for instance, the way you heard about me was because I was giving a talk about state-space models at PyData Berlin.
Yes.
The fun fact is that I didn't know anything about state-space models at the beginning of the year. I just knew the name, and I had interviewed some people on my show to talk about that, precisely to start learning. But I always wanted to learn them and use them in a project. That project came up at work, and so I was like, okay, so now I need to seriously learn how to do that. And one of the best people in the world to do that is Jesse Grabowski, who is the person who gave the talk with me. And so, basically asked him if he wanted to give a talk with me about that. We developed a new feature. The excuse was to develop a new feature for PyMC State Space. That way he mentored me, and that's amazing because it's like learning karate from a black belt mentor on a one-on-one course, every week. So I think it's the best way to learn. Like, just fail faster, fail better, and start with small incremental steps.
Surprising thing about you that I learned is that you studied history at the Sorbonne in Paris. Was it helpful to study history?
No, I don't think it was I don't think it was helpful, but that was fun. I never use it. It's not the degree I use at all. It was fun to study, and I still read a lot of history. I think it's just, curiosity. It was more like a hobby, but I would argue having hobbies and doing stuff just for the sake of it, because this fun is very important to keep in your life, and not always trying to optimize everything, which is definitely something I am biased towards. So I need to control myself sometimes.
If we look at a human as a collection of experiences, and it obviously gets reflected in our work later on, you could say there is no useless experience or no useless knowledge. Because personally, I've studied social science, and when I finished it, I regretted it very much because I taught myself to code, and I always thought, why didn't I study computer science? But now the work I'm doing now isn't that social science in a way. So do you see any connection from history that gets reflected in your work today? Because you work with something like predicting things based on the evidence that you've acquired in one way or another. But you could say that this evidence is, in a way, history?
Yeah, that's a good point. So my scientific brain is always also on. So like I'm always careful in the sense that, well, if you want to find evidence for something, you will find them. I try to find evidence against my hypothesis.
The way I look at people, despite they've done something in the past where they say it wasn't really useful for their work, you could still see this direction, this pattern. So, for example, with history and statistics, of course, those are completely different things, but you could say they share some similarities, one of which is that they are extremely biased. Who writes history books and who analyzes data and comes up with the statistics, in a way, determines the way people get this information. And that's where I found it very interesting that you've transitioned from history to statistics, where you still have to be very careful about the final result you deliver, because in a way, it's always biased.
One of the most interesting questions to me in life is, how do I know that something I'm thinking is true? To me, the scientific method is the best way of understanding with some level of uncertainty where I'm wrong or not, and just learning new things. I absolutely love learning things in my life, and that's always what drives me in every project I start.
Would you say you have more scientific brain, more analytical brain, or more creative?
I do have both, because contrary to popular belief, statistical modeling is an extremely creative endeavor. You have to connect dots and methods which haven't been connected before. And so that's, to me, one of the definitions of creativity. Like, you have to find a way of arriving somewhere without knowing how to do it. And nobody's know how to do it. So you have to create a way. And I do love also writing. So I've done a lot of theater. One of my favorite things is actually doing stand-up comedy. And so I've done a bit of stand-up comedy. I write some from time to time. I write some stand-up comedy when I have the time. So that would be more like the classic creative endeavor, if you want, when people think of creativity. But I do think that I need creativity in my work every day. This is not a very repetitive job. So most of the time I need to tackle new problems that haven't been solved yet.
A lot of people, they think they have to be really good at math and science to even start with statistics. So how much of it is true?
It depends on your objectives. Having studied algebra, I would say, is a good asset. Is a great asset. If I were to study again today, knowing what I'm doing right now, I would study a lot of algebra, and mostly that. And the rest would be physics. Physics and algebra are extremely useful for all the statistical modeling and AI that you're hearing about right now. That is definitely helpful. But that is if you want to develop the new algorithms, I would say, and be really at the frontier. If you want to use these tools, you don't have to know that. That's why we have open source packages. We develop that for you, and you can just use the package and not care about how the algorithms are coded. So you can just use the package, trust us, and go on your happy way analyzing your data. I don't think you need to be extremely versed into statistics. Anything you need, you will learn on the go. And most importantly, I think what you need is just curiosity and an ability to think scientifically, an ability to think against yourself in a way, and always trying to suspend your beliefs or at least question them. This is the most important. The rest is not that important because it's not fixed. Like what you know is not fixed at all. You can change it all the time. Like a lot of people are a bit in a fixed mindset on that. It's like, oh yeah, either I'm good at math or I'm not, or either I know stats or I don't. I'm like, there was a point where you didn't know how to speak, right? And now you do. So like you can learn. It's just like you may not want to, but you can definitely learn. Having that ability to have more of a flexible mindset on that regard and be able to see what you've already learned in your life, which is a huge amount of information. At the beginning, you don't know anything. Like everybody is Jon Snow at the beginning. Right? It's mostly a question of mindset and being able to be very uncomfortable. Like most of my work is being extremely uncomfortable most of the time because I'm learning new things all the time and I need to keep in check these, uncomfortable thoughts, which are at the origin of the imposter syndrome that a lot of people feel in this field, which is, well, I don't know anything because right now what I'm doing, I don't completely master it. But then it's just very short-sighted because you forget about all the things you learned before and you ended up mastering. And that's why you're here today.
The perfectionist mindset.
Yeah, definitely. If you have a perfectionist mindset, that's something you want to work on. If you look at children, they're amazing in their ability to learn. Like they just try stuff all the time. Sometimes completely stupid stuff, and you're like, no, don't do that. You're going to kill yourself. So that's why toddlers are extremely hard to handle, right? You have to be very careful because they can kill themselves, but they're also extremely robust. Like they try things, doesn't work. They try something else. And in the end, it starts working. And I think cultivating that inner child in you is very important.
It's extremely painful to have a perfectionist mindset. It's a way to control the world around you. What helps me is to compare myself to what I was yesterday. Because the problem is that we try to compare ourselves with someone who's maybe spent hours mastering a skill that we just started with.
Or comparing yourself with your ideal version of yourself. There is a very good book actually by Ellen Hendrickson that's called How to Be Enough. She's a psychologist who exactly work on these topics and perfectionism, basically. I definitely recommend it. It's one of the best books I've seen around so far on these topics.
What is Bayesian Statistics? If you could explain it to a 5-year-old or to me.
Yeah, that's a good question because I'm definitely going to do that to my 5-year-old when I have one, the poor little creature. Bayesian statistics is actually extremely intuitive. It is much, much more intuitive than the other way of teaching statistics, which is called frequentist, which is the main way statistics are taught at university for diverse reasons. But Bayesian statistics is actually way older, which doesn't make it better, right? But it was developed much before by a reverend called Thomas Bayes. And actually, that's not very true. Like he discovered what's called now Bayes formula. So Bayes formula is basically the optimal way to update your beliefs given your prior beliefs and the data you observed. So to give you a classic example, let's say you, Olga, are wondering if I'm an alien or not.
I do.
Your prior belief, everybody does. I think I should take the hint. But putting a pin on that.
Take that as a compliment.
So let's say your prior beliefs about that should be very low. Like if you're a reasonable person, you should have a very low prior belief on that. Or if you don't, then you need to have good reasons for it. Extraordinary beliefs require extraordinary evidence. And so that's basically what Bayes formula is about. It's the mathematical way of saying extraordinary claims require extraordinary evidence. And so if you think I'm an alien, a priori, it's a very small probability. But then let's say you get access to one of my blood tests. And in these results, you get the information that actually my blood is blue and not red, like a human. So then actually your probability of me being an alien should increase dramatically. But by how much? That's the question. That's exactly what Bayes formula answers. It's like, depending on what you believed before, and the data you've observed, by how much should you update your prior beliefs into your posterior beliefs. It's extremely useful because it allows you, one, to think and make decisions under uncertainty. And second, it also explains why people observing the same data will have different conclusions. It's because they have different priors. So usually when you see that, it's much more useful not to discuss the data, but to discuss the prior beliefs they have about the topic in question. That's the very basic version of Bayesian stance. That's what Thomas Bayes discovered, but he actually didn't understand at all what he could do with it. He didn't even publish the manuscript. A friend of his published the manuscript when he found it in his room when he died.
Such a common story. Mm-hmm.
Yeah. But then actually the guy who developed Bayesian stats as it is today is a French mathematician called Pierre-Simon Laplace, who actually that's a good story of resilience because he was an extremely talented student, really good, coming from nothing. Both of his parents were poor people in the countryside of France, but he was extremely smart, extremely good at math. So he's and that was in the 18th or 19th century. I think it was 18th. 18th century. And so his math teacher picked it up and sent him to Paris to study with D'Alembert, who is one of the authors of the first encyclopedia, Diderot and D'Alembert. And D'Alembert was a mathematician too. And so he took Laplace under his tutelage, and Laplace actually rediscovered Bayes' formula on his own, and he was super happy. Like he was like, "Oh yeah, that's great. It's gonna make my PhD thesis." And then D'Alembert was like, "Yeah, it's great, but actually, it was already discovered. So
Okay.
yeah, it already exists. It's called Bayes' formula." And so Laplace was crushed, and he was depressed because he was like, "I don't know what I'm gonna do with my PhD now." But then he realized actually, it's not only a formula; it's a whole other way of thinking about the world. It's a whole other way of developing statistics. And so he developed all the framework we have right now to think about Bayesian statistics. And so they actually should be called Laplacian statistics, but that's how history goes, right? It's always the first one who discovers. I always like putting scientific discoveries back into their context because they're always made by people. And often I think we teach math in a very, very dry way because we just teach theorems and theory, and all these theorems and theories were developed by people who were doubting themselves, even though they were extremely talented, or who were in debate or even huge disagreement with other people at the time. And so that science is not at all linear and clean as the education of science makes us think. And we've seen that a lot during the pandemic, because we were seeing science in the making. And to someone like me, it wasn't weird at all, wasn't surprising at all. But then that opened line of argument to bad faith motivated people, which were like, "Oh, you see, actually science doesn't know anything. Like, it's just like it's changing its mind from one day to the next." And it's like, yeah,
Yep.
you should change your mind from one day to the next if the data warrants it. And that's exactly what science is about. It's not at all coming up with theories that are here all the time and for the rest of our lives without putting them into question. The theories that are still here are actually the most powerful one because they can sustain constant attack from the scientific community.
Yeah, also considering that most of the scientists, writers, artists, great people used to live in isolation and used to think in more of abstract forms, also not really cared about, how to make it accessible to public very much. And it's just strange to think that we were just like, yeah, let's just take it and teach it to 15 years old kids who just go crazy when they read these theorems and concepts taken out of the basically rooms of the scientists without any post-processing. So studying math has been extremely difficult for me as well.
Making sure science is put back into context, I think, is very, very important. And also just, we love stories. We're a species who develop stories all the time to pass information. Like all the legends we have from, very ancient times, they were ways to pass on information when we couldn't write or we didn't have printing machine. We love stories. And so I think instead of sticking to a very dry way of teaching science, we should put it more in context and just teach us the story of science instead of just the results.
From a statistician's perspective, how do you understand AI? I have to ask this question.
I think it's really fascinating, honestly. I love learning new things, as I told you. So that means I have a bias, which is I'm usually an optimistic person because I believe that I can learn and adapt. And so that makes me more optimistic in my life. And also it makes me more optimistic in our ability to use technology to answer questions and tackle issues we're encountering. Which is interesting because I know not everybody is like that. And I've definitely had very heated debates with people who are much more basically in a fixed mindset, which is like all these debates around planes, for instance. Planes are are a big, huge source of pollution right now. And so it's very interesting to me from an epistemological standpoint to see people reaching the conclusions that they won't fly anymore, for instance. And why is that interesting to me? Because I think it tells me, and usually that's the case when I start asking them, where does that come from? Tells me that they think things cannot change. And to me, that's very interesting because it's so alien to me. Because my first thought is, what about trains? Like if you had lived 1 century ago, wouldn't you have taken the train? Because trains were extremely, extremely polluting at the time because they were using coal and they were even very dangerous for the people operating the trains, much more than for the pilots who are flying the planes now. But now that's interesting to me because you're saying we shouldn't fly planes, we should only take the trains. But what if people had done all the same thing 1 century ago and then the trains couldn't have been developed and we wouldn't have these extremely efficient and fast trains right now that we have in Europe, for instance? So then if that happened, don't you think it could happen with planes? Like, don't you think in 50 years, for instance, or maybe less, we will develop technology that will make flying not only faster, but much, much more efficient and maybe even better than trains? And that's very interesting to me because my bias is that I always come up almost all the time on the yes side of these type of questions. Each time I have a discussion with somebody who tells me, "Oh no, I don't fly anymore." Usually they are Europeans. I have to say it's a very European bias.
I mean, it comes from the conversation about pollution.
Yeah. No, for sure. And so that's very interesting to me. Like just from an epistemological standpoint, I love having this conversation, not getting to the debate, but because I think it's not interesting. But what's interesting to me is how people come to these conclusions. And usually it's rooted in a way of seeing the world in a fixed mindset. And to me, that's very alien because I always think of the world as changing all the time. And so to come back to your question, I find these Gen AI developments absolutely fascinating. Not only, so first, intellectually, it's awesome because like these models are very interesting. These are huge neural networks. We're trying to understand how they even work, but we know they work. We don't really understand why. And so to me, that's like one of the most interesting questions as a scientist. I think being at the frontier of that is super fascinating. I've obviously been an early adopter of all the different LLMs, and I'm working every day with LLMs, and I'm using that all the time.
The purpose of this entire podcast is actually to give a bit of positive perspective to people, because I agree with you. I'm also on the positive side, and I see things changing for the better, and I believe that people can adapt. How do you think the role of statistician or also the role of a person who has business like yourself would change in the future?
It's already changed a lot. The way I code has changed a lot for the better. It helps me focus on less boring things. Having the AI help me coding is amazing because now instead of spending hours on Stack Overflow, I can just ask Claude or ChatGPT, how do I do that in Pandas again? Or for plots, I spent huge amount of hours coming up with custom plots to explain my models. Making good plots is hard and takes time. And so now with the LLMs, I can get there much faster and even sometimes do things that I would never have done without the LLM, not because it's better, but because it lowers the barrier to entry. So for instance, the state-space models I was talking about earlier. I didn't know anything about that, and I had to contribute to space without knowing the code base. And this is a complex code base. And so here, having access to an LLM was extremely helpful because it summarized the code base for me and it made it less intimidating because instead of staring at the tree file where I didn't even know which file to open, I could ask it question and was like, okay, if I wanted to start working on that feature that I want to add to the package, where should I look first? And probably I would not have been able to do that without an LLM before because it would have taken me way longer. And I don't have a lot of time. I'm doing a lot of things. So if something is going to take months to give some fruits, I have to say no because there are other things I could do and the opportunity cost is higher. So what I think LLMs are doing for people like us is lowering the barrier to entry and helping us lower the opportunity cost of new ventures. And that's great because I think that makes us more creative because it helps us, instead of focusing on the boring aspect of code, it helps us focus on the creative aspects, which is something we are still much better at than LLMs. Maybe we won't in a few years, but we're still much better than them at that for now. And I think it's something, keep developing your creativity because I think that's what makes you human. Like people will still need human connection. Like I think, stand-up comedy, for instance, I don't think it's ever going to disappear because maybe LLMs will be funnier at some point, but we'll still need someone to be on stage and, be vulnerable and make jokes that don't work because I think that's that part where we're not perfect and we're still taking the risk that makes us human and that makes us rely to the person on stage. That's actually something I learned from doing stand-up comedy. Like people will
Imperfection.
laugh more if they see you are imperfect. And if they see you fail, they will actually rate much more because they do fail themselves. So if they don't see you fail, then they put you on a pedestal and they can't relate to you and they will laugh much, much less. So that's why next time you watch stand-up comedy, you'll see how very often the comedian is self-deprecating because that's a way to relate with the audience.
It's very interesting that you're saying that imperfection is something that makes us human. And at the same time, imperfection is something we all are trying to get rid of. But my thought is that maybe I will learn to be imperfect in order to resemble humans a bit more. What's your prediction for how AI will shape the future?
I think we'll make progress in the efficiency of these models, that they will run in a much more efficient way, both computationally and for the environment. I think that, I hope that we'll use them for the best, to get the best out of us instead of doing mostly what politics is doing, is taking the worst out of us. But this is just a hope. This is not what I think. What I think, though, is that it's an extremely, extremely good tool to do anything you want in your life. It's going to help you train much, much faster. Using it as a coach is, I think, what is mainly going to change the world on that front. Now, maybe I'm going to be super wrong and we'll end up using that as we ended up using Instagram and TikTok and just, entertaining us to death. This is definitely one scenario and this is definitely not one I want, but I cannot control that. I'm trying to do things where I'm trying to counter these tendencies we have, but I do think this ability we have to entertain us to death is really something that's one of our worst instincts.
Would you say that being a statistician helps you to navigate the uncertainty? A lot of people struggle with anxiety specifically because they have no idea about the future. Do you feel like you have this toolbox that helps you to view the world in a bit more calm way or maybe more reasonable way?
Yeah, definitely. I'm not sure it's because of statistics. Mostly it's because of epistemology. So, learning more about epistemology and how we know what we know and how does science work in a nutshell is something that really helped me. And that really helps me actively to reason about the world and keep different scenarios in mind and know that a lot of things are not in my control. So this is definitely important for me because I definitely have control freak tendencies. Something that really helps me a lot also is practicing Stoicism. So the philosophy, not the like small s Stoicism, which is like, oh, you don't have emotions, but no, more like
or like suicide.
yeah,
I'm joking.
yeah. And so yeah, no, so much more, like Stoicism from Epictetus, Marcus Aurelius, Seneca. These authors I find had really found very profound insights into the human psyche that really helped me navigate uncertainty, which is, well, not everything is under your control. So if something is outside of your control, try and stop worrying about it. You're just making you miserable for nothing. And one of the most powerful ideas I found from the Stoics is this idea that the obstacle is the way, that what stands in the way becomes the way. And I find an extremely powerful mindset to have in mind. And that's related to, that flexible versus fixed mindset I was talking about. This helps you develop this flexible mindset, which is like, instead of complaining each time there is an obstacle on your way, actually using it and being like, oh, actually that's good. I want this to be on my way because that's making me a better person. And actually, if that obstacle is on my way, that means I am doing what I should be doing. This shouldn't be easy. Like, nobody said it would be easy. Instead of complaining about, oh, this is hard, or, oh, I thought this person was going to help me and then in the end they bailed, or something like that. No, well, that's just, it's how it's supposed to be. Just take it, learn from it, and move on. Yeah, all of that is very, very powerful, I find, at least for me, to help me handle the negative, crazy things we have in life, without forgetting the positively crazy things we also see in life.
It's very interesting. I want to share with you quickly. I don't know if someone has actually researched that topic. I think programming, math, and science in general is something that could be really helpful to people who struggle with control and anxiety, specifically creatives, because that's what I've experienced coming from more of a creative background. A lot of times I felt very lost, especially because of creativity is such a broad concept. And when you come into programming or mathematics, you could of course claim, yes, it's creative, but until you get creative, you have to be very reasonable, very logical, and very analytical. So the journeys are very defined, and that helps you to narrow the focus because you basically just have one path while you're learning. And it has helped me to get a bit less anxious and more calm in life. I find this correlation very interesting.
Yeah, no, that's true. And I think it's also because, like, in programming, you have to fail all the time. And at least for me, it was extremely helpful because I used to be very afraid of failure, especially because the French educational system makes it very bad to fail. Like, anything where you don't have a good grade is bad. So actually learning programming was extremely, extremely helpful for me in that regard, because I spend my day failing and solving programming failures in a model that doesn't work. And actually, models only work in the last iteration. And so, and it's the same thing for computer program. Like, it's only the last iteration that works in a way. And even, you could even argue that it never works. Like, there is always something that doesn't work in a model or in a computer program. There is always some bug somewhere. You just don't know it. But helped me becoming much more comfortable with failure because I just work with it every day, so I get desensitized to it.
I think everybody should check out your podcast. I am definitely going to learn more about Bayesian statistics. You got me hooked. I can see why people follow you and listen to you and get your courses. Thanks so much for talking to me.
Thank you for inviting me. Let me know if you have any comments or any people you would like to hear about on the show. Is learnbayesstats.com. Thanks a lot, Olga, for taking the time and having me on the show. That was a very interesting and original conversation.
Thank you so much.